Hey guys, welcome to a new PyTorch tutorial. In this video we will learn how to use the TensorBoard to visualize and analyze our model and training pipeline. TensorBoard is a visualization toolkit in order to experiment with our models. It is actually developed by the TensorFlow guys, but it can be used with PyTorch as well. So here on the official website we can do a few things. We see a few things that we can do with TensorBoard. So for example, we can track and visualize metrics such as the loss and the accuracy. We can visualize our model graph. We can view histograms. We can project embeddings to a lower dimensional space, and we can display images, text and audio data, and we can profile our programs and much more. So now I want to show you how we can use this in our code. So I'm going to use the code from tutorial number 13 here. Alright, so here is the code. So this is the exact code from tutorial number 13. And if you haven't watched this one, then I recommend that you watch this one first. So I will briefly explain the code again now. So in this tutorial, we used the MNIST dataset. So we did digit classification here. So here we are loading the MNIST dataset. Then we are plotting some of the images. And then we create a simple feed-forward neural net. So this is a fully connected neural network with one hidden layer. So we see we have one linear layer first, then we have a ReLU activation function, and then another linear layer. And that's our whole forward pass. Then we set up our training pipeline. So we have our loss and optimizer. Then we do the training. So here, as always, we do a forward pass, a backward pass, and then update our weights. And then at the end, we evaluate our model and plot the accuracy. So now let's use the TensorBoard for this code to analyze our model a little bit more. And the first thing we want to do is to install TensorBoard. So for this we can do pip install TensorBoard, and this will install all the things that we need. So in my case I've already installed this, so this was fast. And we don't have to install the whole TensorFlow library, so TensorBoard is enough here. And now we can start the TensorBoard by saying TensorBoard, and then we have to specify the path where we save the log files, and we do this by giving it the argument --logdir equals, and by default this is called in the runs directory. So let's hit enter, and then it will start up the TensorBoard at localhost 6006. And here we have a warning that it doesn't find TensorFlow, and it will run it with a reduced feature set, but that is fine. So let's open up the TensorBoard. And now here we have the TensorBoard. And right now we see that no dashboards are active. And this is because we haven't written any data. So let's do this. So let's jump to the code again. And now the first thing we want to do is to import the TensorBoard. So, and for this we say from torch.utils.tensorboard. We import, and this is called summary writer. So we import a summary writer. And so here I have a typo. And now let's create a writer. So let's say writer equals summary writer. And then let's give it a directory where it should save the log files. And the default directory is, as I said, the runs folder. But let's be more specific here. So let's call this runs and then MNIST. And now we have our writer set up. And now the first thing we want to do is here. So here in the code, we plotted some images. And now instead of plotting, let's add the images to our TensorBoard. And for this, the only thing we have to do is we want to create a grid and then call the writer add image method. So let's do this. So let's say our image grid equals, and we also get this from torch vision.utils.make grid. And then let's give it the data. So here we have one batch of our example data. So let's put this in here. And then let's call writer dot add image. And then here we give the image grid. And we also have to provide a label for this image in the beginning. So let's call this, for example, mnist images. And now I want to exit here. So I import sys, so system. And then here I use an early exit because I don't want to run the whole training pipeline right now. So here I call sys.exit, and I want to make sure that all the events are written here. So that's why I also call writer.close. So this makes sure that all the outputs are being flushed here. And now let's save this and let's go to the terminal and let's run this. So let's say Python, and then our file was feedforward.py, and hit enter. And now let's go to our TensorBoard again and let's reload this. And then we see we have our images here. And here we have our grid that we just created. And this is 8 by 8 because we specified our batch size to be 64. And yeah, so now we can analyze our data. And let's go ahead and do something more with our TensorBoard. So the next thing we want to do is to add a graph to analyze our model. So if we scroll down further, then we see that here we create our neural net. So let's comment this sys exit out again. And then here we create our model, and then here our loss and optimizer. And now down here, let's add our model graph. So we can do this by saying writer add graph. And then here we give it the model. And then we also can give it an input. So we can say, again, we have our example data. So this is one batch. And then we have to reshape the same way that we are doing it here. So let's reshape our batch data. And then again, let's call writer.close and writer exit. And system exits. And again, let's run our file. And now let's head over to our TensorBoard again and let's reload this. And then we see here up here we also have the graphs tab. So let's go to the graph, and here we see our model. So we have the input and then the neural net. And now if we do a double click, then we see more details. So here we see our whole model. And so now we see we have the first linear layer, then we have the ReLU activation function, and then we have the second linear layer. And we also see the weights and the biases for each linear layer. So yeah, so now we can inspect this further if we want. And yeah, this is really helpful to analyze the structure of our model. So yeah, now we have our model. And now let's analyze some metrics. So what we did in the original script is we simply, during the training, we printed every 100th step. We print the current loss. So now instead of just printing this, let's add this to our TensorBoard. So let's add the training loss and also the accuracy for this. And for this, we want to have the mean loss during this batch training. So let's add two values up here before we start our loop. So the first one is our running loss. And this is 0 in the beginning. And then let's also say the running correct predictions equals 0 in the beginning. And now every 100th step we, for in each iteration now, we add the loss to the running loss. So we say running loss plus equals loss.item. And we also add the number of correct predictions to the running correct. So for this, we want to get the predictions, and we can do this the same way as we are doing it down here by calling torch.max. So let's do this up here as well. So we get the predicted values, and then we say running correct plus equals, and here we say predicted equals the actual labels, and then the sum. And this is a tensor with only one item, so we can call dot item. And now, here we add this to the running loss, and now every 100th step we want to calculate the mean value and add this to the TensorBoard. So we call writer.add_scalar, and now we have to give it a label. So here let's give it the label training loss. And now the actual loss is the running loss divided by 100, because we sum this up for 100 steps. And then we also have to give it the current global step. And this is the by saying epoch and times the number of total steps that we extracted up here. So this is the length of the training loader. And then plus I, and I is the current batch iteration. So this is the current global step. So here we add the training loss, and now let's do the same thing again and add the accuracy. So let's say accuracy, and then here we have to say running correct divided by 100. And after that, we have to set the running loss and the running predicted to the running correct to 0 again. So let's say running loss equals 0.0 and running loss, running correct equals 0 again. And then, now we have to save this, and now we have to run the whole training pipeline. So let's comment the system exit out again, and now let's run our script, and we should still see the printing outputs here. So for every 100th step we see that how the loss is decreasing, and now we should be done. And now we also see the whole accuracy of our network. And now let's go to our TensorBoard again and again hit reload. And then we have one more entry up here, and this is the scalars entry. And here we have our two plots. So we see that it worked. So we see the accuracy for each of the steps, and we also see how the training loss is decreasing. And so here, by default, TensorBoard is smoothing this line, so we can modify the smoothing parameter here. And now we can analyze how the loss is decreasing. And so, for example, if we see that at some point it is not decreasing further, then we can see that at this point we have to improve something. So for example, what we can do then is we can try out a different learning rate, of course. So this is usually one of the first things that we want to optimize. So let's modify the learning rate, and now let's call the folder mnist, let's say simply 2. And then again, let's clear this and run our script again. And then this should already update our TensorBoard during the file running. So now we see a second graph, and also here we see a second graph in the loss graph. Now let's reload this again, and now it should be done. And now, for example, here we see then another graph with a different learning rate, and this is how we can interactively optimize and analyze our model. And now, as a last thing, what I want to show you is how we can add a precision recall curve. So precision recall curves lets you understand your model performance under different threshold settings. And this makes more sense in a binary classification problem. But if we analyze each class separately here, then we do have a binary classification problem. So let's add a precision recall curve for each class here. And for those of you who do not know what a precision and recall mean, then I have a link for you in the description, so please check that out. And now what we want to do here is, so let's have a look at the official documentation here. So I recommend that you check out this link. So let's search for @PR, and then we see here we have the method @PR curve. So this adds a precision recall curve, and this needs the tag first, and then it needs the labels. And here we see the labels is the ground truth data, so a binary label for each element. And then it needs the predictions, and the predictions are the probability that an element be classified as true, and the value should be between 0 and 1. So this is important here. So we need to have the actual labels and also the predictions here. All right, so now let's go to the code and add a precision recall curve for each class. So here in our evaluation, we want to create a list where we store our labels. So let's say labels equals an empty list, and also a list for the predictions. So preds equals an empty list. And then during the batch evaluation, so what we do here, so for the labels, we can say labels dot append the actual labels is the predicted labels. And now for the predictions, we have to be careful. So for here, we need probabilities between 0 and 1. And now here we get the outputs from our model. And if we have a look at the neural net again, then we see that we have a linear layer at the end. So these are raw values, and here we even have a comment, so no activation and no softmax at the end, because in this case, this is applied in our loss function in the cross entropy loss. But now again, in the evaluation, we want to have actual probabilities. And if you've watched my tutorial about activation functions, then you know which activation function we must use here to get the probabilities. And this is the softmax function. So this squeezes our values to be probabilities between 0 and 1. So let's call the softmax here explicitly for our outputs. And for this, let's import f, so functional. So let's say here, let's import torch.nn.functional as f, capital F. And then down here, we want to calculate the softmax for each output in our outputs. So let's use list comprehension for this. And let's call this class predictions equals, and now here we use list comprehension and call f.softmax, and then here we say of the output. And then we do this, we also have to give it the dimension. So let's say dimension equals along dimension 0. And then we want to do this for output in outputs. And then let's add this to our, what did we call it? Preds. So preds dot append, and then here class predictions. And then when we are done with the for loop, we want to convert this to a tensor. So here we say labels equals, and then torch dot cut the labels. So right now this is a list, and we want to concatenate all the elements in our list along one dimension into a one-dimensional tensor. And for the predictions, we want to have a two-dimensional tensor. So for each class, we want to stack the predictions, and then we want to concatenate this. So we say preds equals, and then here we say torch dot cat, and then here we use list comprehension again and say torch dot stack, and here we stack each batch and say for batch in our predictions. So you should check the shape of these tensors for yourself. So this has shape, I think, how many we have? I think 10,000 samples. So this is 10,000 by 1. And this should be 10,000 by 10. So for each class, we stacked it here. And now when we are done, so now the last thing we have to do is to have the actual PR curve. So for this, we say classes. So our class labels, in this case, it's just the range 10 because we have the digits from 0 to 9. And now let's iterate over this. So for I in classes, and then we say we get the labels I equals. So this is where labels equals I. And then the same thing with the predictions I equals the predictions. And here we want to have all the samples, but only for the class I. And then we call writer dot add, and this is called add PR curve. And this needs a tag. So for the tag, we just use the class label as string. And then here we have the labels first, and then the predictions. So predictions I, and then as global step, we just use 0. And then let's call writer.close, and then we are done. So now let's save this and run our script one more time. And now when this is done, then we should see precision recall curves for each of the class labels. So almost done, and append. So I have a typo here. So I have two different labels variables. So let's call this, let's just call this labels 1 here. So labels 1 and labels 1 and labels 1. And now let's run this one more time. Sorry about that. So let's clear this and run this one more time. And now again, we have to go through the training pipeline. Oh, I didn't save it. All right, so now we are done. So let's reload our TensorBoard one more time. And now we have one more entry up here, and this is the PR curve. And now we should see the precision recall curves for each of our class labels. So here we have label 0, label 1, and so on. And then we can inspect the precision and the recall for the different thresholds. So here on the y-axis we have the precision, and on the x-axis we have the recall. And then, for example, for different thresholds we can analyze it and see how many true positives, how many false positives, how many true negatives and false negatives we have. So this is also really helpful to analyze the model. And yeah, so that's all I wanted to show you for the TensorBoard. I hope you enjoyed this tutorial, and please consider subscribing to the channel, and see you next time. Bye.